Oh yeah, Brianna, I just want to say one more thing.
Okay.
When you start the live stream, you can also we want you to record it as well, and then just send us the files and upload it to
Mhm.
the drive, so then they can like
Okay.
look at it later if they want.
Where in the drive am I supposed to upload them?
I'll send you the link after we're done.
Okay, sounds good. Thank you.
Yep.
Like, do you want me to start recording now or like when I actually begin my lesson?
When you actually begin your lesson.
Okay, thank you.
Oh, Brianna, can you try to make us co-host on the Zoom meeting?
How do I do that? Do I just go to more? Oh, got it. Got it. Yep.
Okay. You can start in 2 minutes. Oh,
Mhm.
just
Wait, all of you guys? No, wait, who?
just Fida and Shrey and me.
Okay. Is it working? I think it's working.
Yeah, it's good.
All right. Cool. Okay. Okay. So it's 3:30, so let's start the session. I'm Brianna. I'll be teaching this second session of the Python workshop. We'll be covering lists, list comprehension, dictionaries, and functions. So to start off, lists. For this, you need to set a variable to square brackets. If you want to add things to an empty list, make sure that your list is defined before you start appending to it. Otherwise, you can just fill it with things at the very beginning. So here we see I have my list name. This can be any variable you set is equal to the empty square brackets. If you want to create a list with values already in it, you put the values between the two square brackets. So if we look at this example below, we see that we can have all different types of values. We can have integers, floats, strings, or even like another list within it. Okay, elements in a list are linked to indexes starting with 0 because in a computer you start counting at 0. So here, if we had list name at 0, we'd have our string 1. List name at 1 is our integer 2, and list name at 2 is our float 3.0. To get all of these indexes, you just put the name of your list followed by the square brackets with your index between them. Okay, so here are some pretty useful functions that you can use on lists. If you use list.append an item, you put a value between the empty parentheses, and this is to add something to your list. If we look at the example below, we have our empty shopping list. Make sure you define your empty list before, and then you can append your items into it. So you have your string food, you have your string eggs, and then if you printed out your shopping list, you'd have food, comma, eggs. If you wanted to remove something from the end of a list, you could just use .pop. You don't have to put an index between the empty parentheses. So if you had your to-do list, your first, second, and last item, if you did .pop, then it'd take out the last item from that list, which is your string last item. Delete list at I. This takes an index between the empty square brackets. So unlike .pop, you have to actually have a number between the square brackets. So again, we have our to-do list. If you wanted to delete the first item in it, you'd put your index of 0. And you see there's a number between the square brackets. If you printed out your to-do list after that, you'd only have your physics test and your computer science assignment. If you just left the square brackets empty, it would crash and Python doesn't know what to do with that. If you want to remove something from your list, you use list.remove and an item. For this one, you have to actually pass in the value of what you're removing, not just like an index. So here we see in our example, in your list, we have hello there friend. You have to actually put in the value friend to take it out. If your value is not actually in that list, won't work because it can't find that item. If you want to find the index of some value in your list, you use .index and then you put the actual value between the empty parentheses. In the example, we have our jobs set to our list, dentist, lawyer, and professor. If you want to index dentist, it actually finds it in the list, so it will print out 0. But if you want to index pilot, it's actually not in the list, so Python throws an error. Okay, and finally we have our length of list. This finds the length of your list. It won't count all the characters inside. It actually counts the number of values separated by commas there are. So if you printed the length of schools, you have 4. Okay, so that covers the intro to lists. We're going to try out this problem and then we'll take up the solution in about 15 minutes. This is an opportunity for you to review what you've just learned and to ask any questions that you might have. Okay, so I'll guide you guys through the solution for this problem. I can share my. Okay. So if I have this file here, I think you guys can see that, okay. And if I make a new file, okay. So we have our problem hot potato. We're going to title this. So you're playing with an n number of friends, which means that the input integer of n is actually one less than the number of people actually playing because it doesn't include you. Because you want to calculate the winner beforehand, that means that you're going to write this code to loop through the number of people until you end up with only one person left. We know that person 1 starts with the potato, and then it continuously gets passed to the person on their right 10 times each round. And every time a player is eliminated, the potato gets passed to the person to their right. Okay, so we know that we have our integer n is our integer input.
Hey, Brianna.
Yep.
Try sharing your whole screen so that after they'd be able to see the code as well, because I only see the idle right now.
Oh, wait, okay.
Yep.
Sorry. Is this okay? This is good?
Yeah,
okay?
that's good. That's good. That's perfect.
All right, perfect. Okay. So we have our n, which is our integer input. And then we know that there's one extra person playing because that's you. We know that we need a for loop. Oh, wait, we need a while loop first. So while n is greater than 1, because this means that there's at least one person left playing. We should probably set up our list first. Okay, we're going to set up our list first. So we have our players is n4. Oh, I didn't teach that part yet. Okay. We're going to set up our empty list of players. And then you can do a for loop for I in range number of players plus 1, because you have to include yourself. You can add dot append your player number plus 1, because we want to start with player 1, not player 0. So if we start with I plus 1, then we're starting to count from 1 and not 0, because I starts at 0. Okay, so now we have our players set up, and we can actually use that. So we can use if the length of our players is greater than 1, that means that there's at least more than one person playing. Then we can run through the 10 switches of positions. So for j in range 10, we need something to keep track of our position. So we have our position starts at position 0, player 1. And then we need to make sure that our position doesn't go out of bounds for our list of players. So we need to mod that by the length of our list. Okay. Does this make sense so far? Okay. I hope you guys are all doing okay. Okay, so now we know that we're looping through our positions 10 different times. We have that set up, but we need to eliminate the person at the last spot every loop. So we can use our delete players at our position. But what if our position is the last player? So if the length of our list is like 4 and we're at player number 5, yeah, we're at player number 1, 2, 3. We're at player number 4. Okay, if we're at player number 4, as soon as that person gets taken out, the length of our list is actually only 3 now, but we're currently at index 3. But that doesn't exist in a list of length 3. So that means that we need to mod our position again by the new length of our list. Okay. And if you're not sure if this is working properly, it's always best to print out the person getting eliminated each round. Okay. And then at the very end, that means that the length of players is no longer greater than 1, which means that we've only got one person left, which is the position that you want. Then you print out the last person, and the last person will always be at position 0 because there's nobody else with them. Okay. And if we want to run this, I can't get to, okay. You can just save it as. If we ran this, then we have our number of people playing. If we tried 3 people, then we know that person 3, 1, and 2 gets eliminated. So you want to be at position 4, which matches our solution. Our winning position is 4. Okay, I think that's the solution for this question. If you have any questions, don't hesitate to ask. I think I'll give you guys another practice question with lists. So let's pretend that you're playing Frisbee, and every time you throw the Frisbee, it goes to every other person. So instead of moving 1 over each time, you're actually moving 2 positions over each time. I'll actually type this out for you guys so that you can read it. Okay, try that out and we'll take this up. I'll give you guys a full like 10 minutes to do this question because you have this layout set up already. Okay, try that. Okay, so now we're going to do this new Frisbee version. You're just moving 2 positions to the right each time instead of only 1. So here we have our integer input that still stays the same. You have your players, and you set up your players in the same way that you set up the hot potato way. And of course, you need something that keeps track of your position. So in our while loop, again, you want the length of players to be greater than 1. So it's elimination Frisbee, I guess. You get taken out each time the Frisbee gets thrown to you, and you don't want that to happen. You're moving to the side 10 times each time, but instead of adding 1 to your position each time, you're actually adding 2. All right, so if we start at position 1, at position 0, they throw to the person in position 2, which would be player 3. Okay, and like in hot potato, you have to mod your position by the length of their players in case it's person in the second last position throwing, in case it's the person in the last position throwing to the person in position number 1, which is player number 2. Okay, and to keep track of what we're doing, we want to print our players at that position, and then we want to take them out after because they got eliminated. And just like before, in case the person is the last player in line, we need to remod our position by the length of players. Otherwise, it could be out of range. And then we want to print the last person remaining. So if we ran this, let's change our title. Okay, if we ran this, then if we only had 3 other friends, so 4 players, then we see that we go from, we eliminate the first person, then the player number 4, then player number 2, and then our winning position is now 3 instead of 4. Okay, let's continue with our lesson. Okay, so list comprehension. If you want to fill a list quickly with a bunch of values or change the values contained in a list, you can use list comprehension. This is super useful. If you want to fill lists with items, our first example here is list of lists. So you can fill a list with empty lists. Here we use what we want to fill it with, which is our empty list for I in range 10. This is a for loop that goes through, and each time I increases, we add an empty list, which means that we'd end up with 10 empty lists in our list of lists. And using that, you can fill it with different values later. For our list of zeros, you have 0 for j in range 5. Again, you have the value you want to fill your list with, and then how many of that value you want in your list. This would fill your list with 5 integer zeros separated by commas. And here you can also fill your list with a bunch of strings. So if you had hello for k in range 100, you have 100 hellos in your list, and you don't have to use a for loop to add them. Well, you do here, but you don't have to have so many different lines to add your hellos. It doesn't seem very useful here, but you never know if you want to use that somewhere in your project. So what can you do with your first example? With your list of lists, you can actually append things to a specific empty list in your big overall list. To do that, you take your list of lists at 0. That would be the first empty list in your list of lists, and you append something to it. So I append the string something to the first empty list. If you want to retrieve that value, then you do list of lists at 0, which would be the first empty list at position 0. So this is index 0 in the first empty list in the overall big list. Okay, what can you do with the second example? So for this one, you have a bunch of different zeros. You can actually keep track of different values throughout like a project or a problem. To do that, you just, like a normal list, you take out that value at index 0, and you can add 1 to it. You can actually put in any index that's within your list, and you can perform any other operation to that integer. And if you want to retrieve that value, it's like a normal list. You put your index between the 2 empty brackets, and you have your name of your list. Okay, what about changing values in lists? So we can look at our example. We have our defined nums list as 1, 2, 3, 4, 5. If you printed that out, it's just the normal list. You can do double nums, so you can multiply each integer in that list by 2 for every integer in that list. So for n in nums goes through each integer, and then you can multiply that by 2, and it adds it into your double nums list. If you printed that out, you'd end up with 2, 4, 6, 8, and 10. You can also divide everything by 2. So you have your n divided by 2 for n in nums. And if you printed that out, you'd end up with floats because you're now like going to 0.5 territory. And that works very similar to the first example here. You can also manipulate strings. So if you had your new words is word plus string 0 for word in words, it goes through each word in your list and it adds 0 onto the end. So you'd end up with word 10, word 20, and word 30. Okay. And if you wanted to create boundaries, so let's say you only wanted to add a number multiplied by 2 into your double nums list if that number was even. So you'd see in nums we have 1, 2, 3, 4, 5, but in double nums, because you're only multiplying the even numbers, you'd end up with only 4 and 8, because 2 and 4 are even numbers in our original list. Okay, let's do this problem together. We have our manager of a store named Penny, and she has super weird preferences. She really likes even numbers, but she really hates long code. And your job is to create to keep track of all the items in the store and report them to her. But you want a promotion, so you make sure that she only sees the even numbers. And you also want to get a holiday bonus, so you're going to code it in under 5 lines. I need to open a new file. Okay. Okay. So we get an input of different integers all in one line, which means that that would actually be a string. So we can have our nums equals to input, and you can actually split that input as soon as you get it. This split would actually look at the input and split it at every space. So here, because you have 1, 2, 4, 6, and so on, you'd end up with 1, 2, 4, 6, all in a list called nums. And they can go through and only keep the even numbers. So your new nums is equal to your n for num in nums, but only if your number is even. Okay, and then you can print out your new numbers. So we have, let's say we have our numbers 1, 2, 4, and 4 and 6. Oopsies, what's wrong with this? Okay. Oh, right, okay. So what I missed here is our input is actually a string. So when you split it, it's still a list of strings, and you can't mod a string. So that means that we'd have to do int num. So we'd have to typecast and make our number into a integer if our number mod 2 is 0. This should be okay. And we only see 2, 4, 6, which means that the 1 just disappears and Penny never sees it. All right, and we count our lines. We've only got 1, 2, 3, 4, 5 lines, including the title. Perfect. Okay, if there's any questions with that, you can ask me and I'll get back to you. So now we can move on to dictionaries. So these are like fancy lists. In lists, we used indexes, so numbers that kept track of each value. We start at 0, so 0, 1, 2, 3, 4, also on into our list. But dictionaries, you have to actually define your own index for every value, and we call those keys. In the example below, we see our defined dictionary. Instead of having that set to square brackets, which is for a list, you set that to curly brackets for a dictionary. And again, you make sure that you define your dictionary before you try to add stuff into it, or you can just define it originally with stuff in it already. Here we see dictionary at apple would be fruit. In this case, apple is our key and fruit is the value that it corresponds to. We see the return of the square brackets, and that's what you use when you want to add values or retrieve them. And we remember in our lists, our index always went between the square brackets. We can look at our dictionary at key of broccoli would be a vegetable. Dictionary at the key of 0 is our number. And dictionary at key of float is 0.8. You can mix up different values and different types of values. So if you printed out dictionary at apple, you get fruit. You can also define your dictionary with stuff already in it. For that, you put in your key, followed by a colon and the value that it's supposed to correspond to. So we have apple corresponds to fruit, and 0 corresponds to number. Okay, let's go through this problem together. So we have our grandfather Bob. He has a lot of trouble remembering where he can find each item on his grocery list. But because you're a really good grandchild, maybe even the favorite, you can create a food dictionary containing the following items and where to find them. So for this, Bob really likes fruits and vegetables, and we're going to look at how we can do that. Okay, we're actually just going to use this. Okay. So for this, because you have all your values already given to you, you can create your food dictionary before you actually take in any input. So we can set up our food dictionary. And we remember that we need to use curly brackets for this. Within that, we know that our apple is corresponding to our fruit aisle. And because we see that aisle is every word is followed by aisle, we can actually just add that to our output at the very end. And we can copy and paste this for our different values. Wow, okay. Lemon goes to our fruit. And then finally we have our finally we have our watermelon. Okay. And then now we're on to our vegetables. For this, it's generally the exact same as what you just did, just with vegetables. And this is to review what you learned about dictionaries. Okay, so now we have our food dictionary set up, which means that Bob can now use it. And here we notice that he'll only be typing in all caps, apple instead of apples, so singular instead of plural, and in all caps, okay. So we can take in our input. So the food he's looking for is equal to our input. We don't have to worry about converting them all into all caps or taking off any S's at the end. First, we need to check if it's actually in our food dictionary. For that, we can use if food not in food dictionary. So if it's not in our food dictionary, then we print out not on the list because he does not need it. Otherwise, it's actually in the food dictionary, so we just print out our food dictionary at that key. Plus our word aisle. Whoop. Okay, let's see how this works. So let's say he's looking for carrots. That should give us the vegetable aisle. Very good. Okay, so because we're doing really good on time, I'm going to have you guys convert this into a for loop. So what if Bob wanted to find multiple different foods at once? If you wanted to find an apple, then a broccoli, and then a carrot, right? You don't want him to have to restart the program every time he's looking for a new food. So we're going to try that out. Yeah, and you also need to make sure that you have a way for him to exit the for loop. Okay. Okay, so we're going to take this up now. We're just making this into our for loop. So we can take this, indent it. Actually, this shouldn't be a for loop if you want this to go in limit. Okay, so we can have for I in range. Let's pretend that at most Bob is going to go through everything on his list, which is like 9 things. So this would be our for loop. We can try to make this a while loop afterwards. So for I in range 9, he can go through and search up as many things as he likes. But if we wanted him to make this, or to be able to use this an unlimited number of times, you'd actually make this into a while loop. Whoopsies. Okay. So let's use a while true loop. So we can have him continue to input things until something is not on the list. So if the food is not in our food dictionary, we actually don't need to put this inside our while loop. We can actually put this outside. Okay, so while true, if our food is not in the food dictionary, then we can print out not on the list. And then otherwise, and then we break out of our loop here. Otherwise, we print out where it is. Okay, so while true, our food is our input, and if it's not in the dictionary, then we print out on the list and we can break out of it. Otherwise, we just print out where it is. And we can run this. Now Bob can search for carrots, apples, and if he prints out something that's not on the list, cereal, not on the list, and we exit our while loop. Okay. Let's continue on to our last topic, our functions. So to create a function, you start with your keyword of def, so def, followed by the name of your function. Def just stands for define. You're defining your function. So let's look at the example. Def say hello, print out hi there. And if you want to use your function somewhere in your code, you call it, which means you put the name of your function followed by empty parentheses. In functions, you need to be really careful when you're using variables, because variables declared inside of a function are called like local variables, and they don't exist outside of it unless they're made global. Well, I'll clarify that in a bit. So let's look at this. If we define our function define variables, and we have our variables, my string is string of fruit, my integer is 19, and Boolean is true. If you wanted to print these variables outside of that function, they won't work because they don't exist anywhere outside of defined variables. You can even try that out if you don't believe me. But if you define your variables outside of your function, so we set them to values outside, and then you change them inside your defined variables function by making them global, then it will work. If you didn't make them global, they still wouldn't change and they'd remain their original value. And while global is pretty useful, it's not the best style. So what you want to do is actually use parameters or arguments and then return a value. So we can update this function into add1, and we pass in a parameter of num, and then we add one to that number and we return it. Okay, return it is a keyword that tells Python what to give back, but we'll also see what it can do later on. This function actually doesn't store the new value for our variable num in memory, and it actually doesn't print it out either, because it's just returning it so that you can use it somewhere else in your code if you actually did store it in memory. What you can do is you can just print it out immediately. Again, it's not stored in memory, but it's outputted so you can still see it. So this would output 9. Otherwise, you can set it to a variable so that's stored in memory. So we set our value to add1 8, and if you printed that value, you'd have 9. Okay, return also tells the function to terminate, which means that it exits the function. So let's say we have our function how you did on some test or quiz, and you passed in your mark. If your mark is greater than 80, then you return good job. We see mark greater than 70 and mark greater than equal to 5 all contain marks greater than 80, but if your mark is greater than 80, it actually sees the return value and then it won't check anything beneath it. So it'd return good job and then you're done. Then if your mark is greater than 70 but not greater than 80, you return pretty okay and then nothing else. If it's only greater than or equal to 50, then it return you passed and nothing else. Otherwise you failed and it's a yikes. Okay, we're gonna do this last problem and then I might give you guys an extra like twist on it to make sure that you guys are understanding. Okay, so we have our store greeter. Due to our worldwide pandemic, you can't greet your customers in person. Instead, you have to send a digital hello to every visitor to your online store. And it's going to be a lot of hard work to type out hello or hi or whatever to every person that's on your website, but you can actually create code that does it for you. So we're going to create a function named greet that takes in a customer's name and then outputs a nice welcome. So let's say, we can actually define our function before anything else. So if we define greet, and we needed their name, right? So we set our parameter to their name. Then we return their name plus a nice greeting. So we can say just hello name, I guess. Okay. If we tried this, remember you have to actually either store this in memory or print it out immediately. So we're going to print it out immediately. Let's do greet. There you go. Oh, we need a space between it. Okay, and you have your hello friend. So instead of just greeting a specific person, let's say if their name starts with an A to an L, you greet them using a different greeting versus if their last name, if their first name starts with M to the end of the alphabet. Okay, and I'll give you guys a little bit of time to work on this, and then we'll do it together. Okay, we're going to look at how we can do that so we can keep our greet name for this one, and we can just create a new greet, so greet2. And these are both very similar. We can just return hi. So while you're able to create a whole string of letters and then go through and check to see if the first name starts with one of those letters, I'm pretty sure you could probably use ASCII values for this. So we have our name as our input, or that's not a good idea. And then if the character at the first position in person, 0, is between the ASCII values for A and L, we can actually find the ASCII value for A here. That's 65, so it's between 65 and L, whoopsies. So it's between 65 and 76. This means that the first letter of their name, if capitalized, starts with either an A all the way down to an L. Then we can just greet them using the first one. And then otherwise, we use the second one. Whoa, okay, we're gonna start a new shell. Okay, so let's say our name is Abby. I forgot the space again, okay. Okay, yeah, so Abby starts with an A, which means that it fits into the first one. And if we tried a different name, I don't know, what's a name that starts with a Z? All right, hi Z, there you go. Okay, and because we're like doing really good on time, I think I'm gonna introduce an extra concept here. It's called recursion and it's pretty cool. We can take something like factorials. So if we created a function called factorial and we take in a number, an integer, we can actually like calculate this factorial using recursion. So if our number is equal to 1, we know that 1 factorial is just 1, right? So we return 1. This is what we call a base case because this is where you can't recurse any further. That's your last like ending value. Otherwise, you want to multiply it by the number 1 less than the current one. So you return n times factorial of n minus 1. All right, and this is what actually causes the recursion because here it sees, okay, so n is not 1 yet. So if n was 2, then you take 2 and you multiply it by the factorial of 2 minus 1, which is 1. But you see when you pass in 1 for n, it returns 1. So it sees 1 here and you multiply 1 by your 2, which would give you your 2. So we can try factorial or print factorial of 2. And it gives you 2. Okay, and we can even trace out the outline for this if you want like a bigger number. Like let's say 5's such a big number. Okay, so if you had 5, right? You pass in 5 for n. It sees 5 is not equal to 1, so it won't return 1 yet. But it sees that you multiply 5 by the factorial of 5 minus 1, which is 4. So you've got your 5 times your factorial of 4. Then you go through with 4, right? It sees that 4 isn't equal to 1. So it would return 4 times the factorial of 4 minus 1, which is 3. So you've got your 5 times 4 times the factorial of 4 minus 1, which is 3. And then it goes through with 3 again. It sees that 3 is not equal to 1, so it doesn't return your 1, but it will return 3 times the factorial of 2. And it continues to grow, and we know that our factorial of 2 is 2 because it goes through with 2. It sees that it's not 1, and it will return 2 times the factorial of 1. And because 1 is our base case, it returns 1. And then with that, we've got our 1 times 2 times 3 times 4 times 5. So we see that would give us some number that, I don't know, 120. Okay, this is pretty cool. It's just the last concept I'm going to leave you guys with. And yeah, I think that's going to conclude our session for today. Okay, stop sharing. Cool. Okay, that's the end of our session. Have a good day, and I hope you guys enjoyed the rest of your MasseyHacks experience.